Okay. Since we already discussed the fundamental theorem about definite integral, it is time to discuss some of its application. So, our first application is about area between curves. How do we get the area between curves? Using the fundamental theorem of calculus. Suppose that we want to find the area of a region bounded by the graphs of two functions f of x and g of x as shown at the right. Okay, this one. How do we get this area? Okay. Given the two functions f of x and g of x. Note that the area of the desired region A, this one, the area of this region is the area of A sub 2 minus that of A sub 1. So here's the graph. Okay. Okay, this is A sub 2 and this is A sub 1. So the difference of A sub 2 and A sub 1 is equal to A. So therefore, this area A is equal to the integral. The integral of a function is the area of the region under the graph. Okay. So A sub 2 is the integral of f of x dx for interval a to b and minus a sub 1 integral of g of x dx from a to b. Okay. Again, our basis is the integral or the area is equal to the integral of the function. Okay. And the area is the region under the graph. So we can combine this using a property of integration. And we have this one. A is equal to the integral of f of x minus g of x dx from a to b. So for this one, always remember na for for two curves, the area in between two curves is equal to this. Since our basis here is a vertical rectangle, as discussed sa Riemann summation, since we are considering vertical rectangles, this one is the height of the rectangle. So it's the upper graph minus the lower graph. So since our upper graph is line f of x and the lower graph is g of x. So it's upper graph minus the lower graph dx because we are analyzing a vertical rectangle. So we are going to use this one in solving problems. Okay. Always remember upper graph minus the lower graph. So in general, we have the following theorem. Let f and g be continuous functions and suppose that f of x is greater or equal to g of x over the interval ab. Then the area of the region between the two curves from x equal to a, x equal to b is the integral of f of x minus g of x dx from a to b. Assuming that f of x is greater than g of x. So it's always upper minus lower. If ever g of x is greater than f of x, then our integral will be g of x minus f of x. So here's our first sample problem. Find the area of the region bounded by the graphs of f of x equal to 2x plus 1 and g of x equal to x squared plus 1. So first is we make a sketch. We're going to sketch the two functions f of x and g of x. We make a sketch as in the figure at the right to determine which is the upper graph. because notation lang ang f of x and g of x. So we still have to determine which of the two functions uh, which of the two functions is higher. No. And so we have this one. Okay. F of x is a line, and if you substitute x equal to 0, then f of x is equal to 1 this point, and then f of x equals to, if x equals to, then our f of x is equal to 5. Okay. And then you just connect 2 points and you have the line. G of x is a parabola opening upward. And if you substitute values of x, like when x is equal to 0, g of x is equal to 1. And if x is equal to 1, g of x equals to this one, this point, and so on. If x equals 2, then g of x equals 5. So by graphing, we are able to determine the points of intersection. So to calculate the points of intersection, we set f of x equal to g of x and then solve. So this is what you're going to do always. And to calculate the points of intersection, always equate the two functions para makuha ang point of intersection. So f of x equals g of x. So 2x plus 1 equals x squared plus 1. So makancel ang 1 and this is the result. 0 equals x squared transpose 2x negative 2x. And then you factor out x, you have this. And to solve for x, the idea is if the product of two factors is 0, it means na one of the factors is 0. So it's either ang x is equal to 0 or x minus 2 is equal to 0. So x minus 2 equal to 0, therefore x equals 2. Okay. So first point of intersection, x equal to 0, y equals 1, and x equals 2, y equals 5. So the graph intersects at x equal to 0 and x equals 2. We see that over the interval 0 to f is the upper graph, the blue line. So we now compute the area as follows. Integral of f of x, f being the upper graph. Okay, this is f of x to x plus 1 minus g of x squared plus 1. So this is f of x and then g of x. And so you get the antiderivative. Simplify, 1 is cancelled, 1 minus 1. So 2x minus x squared. And then you integrate from 0 to 2. And then evaluate upper limit minus the lower limit. 2 square is 4, 2 cube 8 over 3 minus 0 is 0. So the answer is 4/3. So always remember upper minus lower. Another one. Find the area bounded by the graphs of y equal to 3 minus x and y equal to x squared minus 9. Okay, so the first function is a line and the second is a parabola. Okay. So instead of f of x and g of x, ang given sa problem as is y. y and y. So first, let us plot the line. The fastest way to plot a line is using intercepts. Okay, like when x is 0, y equals 3. When y is 0, x equals 3 also. So for this one, x is 0. 0 ang x, y equals 3. Now, pag 0 sa dang y, 0, 3 minus x, transpose x equals 3. Dili scaled ang 1. Dili lang scaled ang drawing. So with these 2 points, you connect the 2 points and you now have a line. Okay? And the equation is y equal to 3 minus 6. The second one is a parabola. So when x is 0, y equals negative 9 here. And when y is 0, x squared equals 9. So x squared equals 9. You solve for x, square root of 9 plus and minus 3. So there are 2 points, positive 3 and the other one is negative 3. And then i-connect mo, you have a parabola. So after sketching the graphs, you now have an idea that the line is the upper graph and the parabola being the lower graph. So next is to determine the point of intersection because that will be our limits. So one point is this one, x equal to 3, and the other point is this. I mean, this is the equation of the parabola. Okay, this is the second point of intersection. What's the value of x? Eh? What's the value of x? So to determine this point, okay, we equate the two functions. F of x equal to g of x, or simply y equal to 3 minus x equal to this one. 3 minus x equal to x squared minus 9. Simplify, you have this one, x squared plus x minus 12. And you factor out x plus 4 times x minus 3. So x should be negative 4 and x equal to 3. Therefore, this is x equal to, this is negative 4. Okay. And this is our bounded region. Okay. So, to have your guide, let us consider one differential rectangle para this will serve as our guide. So the upper value is line minus the lower value or the lower graph parabola. So the area is line, okay, line minus parabola. And then dx man, x from negative 4 to positive 3. So simplify and then you integrate, and then after that you evaluate upper limits and lower limits. So 12 times 3 minus 3 square 9 over 2. 3 cube is 27 divided by 3, it's 9. Minus lower limit, 12 times negative 4, it's negative 48. Negative 4 squared is 16 divided by 2, 8. So minus 8. Negative 4 cubed is negative 64. Times negative, that's positive 64. And the area is 343 over 6. Next one. Find the area bounded by the graphs of y equal to x squared and y equal to 2 minus x squared. For x greater than or equal to 0 or less than or equal to 2 or from 0 to 2. Okay. So first is sketch na to ang graph. So for this graph, y equal to x squared, it's a parabola opening upward and ang vertex is at the origin. Bali, when x is 0, y is 0. Ba? And when x is 1, y equals 1. When x is 2, y equals 4. So, naas first quadrant. Sa second, naasa, no? Like, when x is negative 1, y is 1. When x is negative 2, y is 4. So, symmetrical sa. Eh. But since our limits is from 0 to 2, then let's just consider the portion sa first quadrant. Fourth, to the right of the y-axis, first and fourth quadrant. So the graph of this function y equal to x squared is this. The other half is the second quadrant. For the second function, if x is 0, y is 2. Sorry. This is the equation. For the second function, when x is 0, y equals 2. And if x, for example, if x equals 1, y equals 1. When x equals 2, y is negative 2. Therefore, the parabola opens downward. Open downward ang parabola. So, here's the graph. The other half is there. Okay. Now, this is the equation 2 minus x squared. So, again, we will locate the points of intersection by setting the two functions equal. So, we have this point, point of intersection. X squared equal to 2 minus x squared. So, transpose 2x squared equals 2. Cancel. X squared equals 1. So, ang x na to is plus and minus 1. Of course, because the other half of this parabola opening downward and opening upward, they will intersect sa second quadrant na 1, where x is equal to negative 1. But since our limit is from 0 to 2, then we will only consider this point x equals positive 1. Uh, since our interval is from 0 to 2, we will only consider this area. Area 1 and area 2. Now, you will notice na nag-change ang graph. From 0 to 1, the upper graph is this parabola, 2 minus x squared, and the lower graph is the parabola x squared. While from 1 to 2, the upper graph is x squared, and the lower graph is 2 minus x squared. So we have to break this area into two integrals, like this one. So if you consider a rectangle, uh, pink minus blue, uh, while from 1 to 2, it's blue minus pink. So this is area 1, from 0 to 1. Upper minus lower, it's 2 minus x squared minus lower x squared. And from 1 to 2, upper minus lower, it's x squared minus 2 minus x squared. So 2 minus x squared, that's 2 minus 2x squared. X squared minus 2 plus x squared, so 2x squared minus 2. And then you integrate, and then after that you evaluate. 2x minus 2x cubed over 3, so 2 thirds x cubed from 0 to 1. 2x cubed over 3 minus 2x from 1 to 2. So you evaluate upper and lower limits. 2 times 1, 2 thirds, 1 cube. Lower limit 0 ang x, 0. 2 thirds 2 cube is 8 times 2, it's 16 over 3. 2 times 2 minus 4. Upper minus lower limit. X equal to 1, so it's 2 thirds. 2 times 1, negative 2. And then you compute the area is equal to 4. Okay. So always remember that when you use the fundamental theorem of calculus about the definite integral, and considering a vertical rectangle, okay, the area is the integral of upper function minus lower function dx. So I hope that you have learned something sa presentation. Thank you for watching.